Alright, let's solve this standard sliding window problem today, which is max consecutive ones. It says, given a binary array nums and an integer k, return the maximum number of consecutive ones in the array if you can flip at most k zeros. If we take a look at the example 1, you can see the input and our output is 6. The explanation is bolded numbers were flipped from 0 to 1 and the longest subarray is underlined, meaning this particular one was initially 0 and this one was also initially 0, but we flipped them to 1, making the length of the longest subarray to be 6. Let's go ahead and visualize this and understand better. Alright, I have our example 1 here, and to solve this problem we are going to use a sliding window technique to keep track of how many zeros you have encountered so far, and whenever we encounter more than the number we are allowed to flip, we simply get the length of the current subarray. So let's say we create a variable called z, which will initially be 0. This variable is going to keep track of how many zeros we have seen so far. So we initialize our left and right pointers, which will be at index 0 by default. Now we keep on shifting our right pointer until 0 becomes greater than the amount we're allowed to flip. So if we keep on shifting it from here, at this point 0 should be 3, because here we increment 0, here we increment it, and here now it's greater than 2. So after flipping at most 2, our length becomes from here to the end, making our length to be 5. Now what do we have to do next? We have to shift our pointer, our left pointer, until the number of zeros we have encountered becomes less than k. So for that, we'll shift our left pointer from here all the way to this place, and then increment our right pointer, because now our 0 will be 1. We now have to increment this right pointer again. Our left pointer is currently here. We now have to increment our right pointer again. Now we've encountered a 0. We simply calculate the length. If we flip this and flip this, the length becomes the maximum between our 5 and the new length, which is 6, making our answer to be 6. So let's try to write the code and understand better. Okay, so the first thing we are going to do is to create our max length variable, which we will return later. We'll use this variable to keep track of the maximum length we have encountered. So you can call it max length 0 for now. Then we create the variable that will keep track of how many zeros we have encountered so far. So let's call it zeros. We have encountered none by default, so it's 0. Now we create our left pointer, which will be 0. We now have to loop. Let's call it for right in length of. We'll check if the number at our right is 0. We increment our zeros by 1. And also we check if our zeros ever gets greater than our k. We want to update our max length to the maximum between max length itself and our right minus left. Now we also want to keep on shifting our left pointer until our zeros become less than k. So you can do y zeros is greater than k. We want to do if number at our left pointer is equal to 0. Let's minus 1 from the zeros. Then we simply want to shift our left pointer. Then at the end of the code now, we also have to check this. If our zeros is less than or equal to k, we want to also update our max length if possible. So why? Because if we take a look at our example here, when our left pointer was here and we kept on shifting our right pointer to this place, our zeros never got greater than 2. So but it's 2 and 2 is valid. So at the end of the code, we just want to check if our zeros is less than or equal to k. Let's update our max length if we can get the maximum from there. So finally, we just need to return our max length. So that's it for this program. Let's now run the code and check if it works. Alright, so it works, and that's it for this video. See you guys on the next one.